So once again, this is about buffer, and we're talking about what's the relationship between concentration and its buffer's capacity. And I'm going to go, this is going to be a little different in that I'm going to do a modeling of it, and then I'll draw it for you with the notes. So to buffer in the chemistry term means it's resisting change in pH, or to buffer to like slow down something, but it really means pH resistance, keeps the solution the same. All right. Okay, as we've seen from the Henderson-Hasselbalch equation, a buffer's pH depends upon its concentration of its weak acid and its conjugate base. All right. Now, this thing would have a certain pH. All right. And if they're equal, then it's just the pKa value of the acid. Now, I can increase the concentrations of both my conjugate acid and my conjugate base, or base, acid, and base. Now, I've got 6 and 6. They wouldn't be so segregated. Now, I've got equal amounts of acid and base. Therefore, the pH is going to stay the same. It's still going to be the pKa. However, I'm going to have a greater capacity, a greater buffering capacity to acid and base because I've got more of each species. All right. And if I continue, I add 2 more, and I add 2 more. All right. And then I add some more, and I added more. All right. Now I've got 10 and 10. Once again, the amount of each, or the ratio, has remained constant to each. The amounts have gone up. My concentrations of both my acid and base have gone up, but their ratio to each other has remained constant. And in this case, it's equal. Therefore, I don't affect the pH, but I get a greater buffering capacity. Now, it makes logical sense, therefore, that if I take away one of my species, let's just say I take away my acid, this buffer would have a greater capacity. If it's got more base, it would have a greater capacity to buffer acids rather than bases. All right. And the opposite is true if I take away the conjugate base. If I've got a lot of conjugate base and not a lot of the acid, then it's got a greater capacity to buffer acids than bases. Okay, now I'm going to repeat this in like notes. Okay, so there we go. All right. Now to show this in a particular drawing, I've got 2 buffers here, and here's my conjugate acid and here's my base. You can see I've got a certain amount of each, and I've doubled them both. All right. What does that do to the buffer? So here's what happened to the concentrations. But this is true because that's of Henkel-Hasselbalch's equation. In all of these, or in both of these solutions, these pH would just be the pKa of my acid. Now it's talking about this. It's really talking about this buffer, the one where you've got more of them in there. Okay. Now to show buffers that I've got different concentrations of their conjugates, acids and base. If I've got one that's got more acid than base, all right, where my concentration of my conjugate acid is greater than my conjugate base, then this thing can buffer base better, all right? And the opposite is true over here, where if I've got something that's got more conjugate base than acid, it can buffer acid better, all right? And that's all about. Please let me know how this helps, and I hope you're doing well.